Alright, final angle measures. So if you draw yourself a picture to look at, and if you just make up your own angles, knowing that those lines are parallel. So if you say that's 80, that's 100, that's going to be 100, that's going to be 80, and then it's going to be the same. 100, 80, 80, 100. Okay, now you can look at that. So if you stare at these two angles, the big question is, are those two angles supplementary or are they congruent? And if you don't know, then draw your template. Look at your little picture, and those two match up with these two, which are supplementary. So your move is going to be x add 73 add 121 add x is going to equal 180. Those two angles summed together should be 180. So do your math, and you got 2x plus 194 is 180. So subtract 194 minus 194. You got 2x equals negative 14. Divide by 2. Divide by 2. You calculate x to be negative 7. But then you have got to plug x in. So if I plug x in right there, 121 minus 7, that angle should be 114. But let's just check to make sure. 73 take away 7 is going to be 66. And 66 add 114 checks. That is 180. So fill in all the rest. That's 66, that's 66, that's 66. That's 114, 114, 114. So the question is, are they supplementary or are they congruent? Number 2 is one that is congruent. If it's congruent, you got 12x minus 8 is equal to 10x plus 10. And then if they're equal, just do the equation, solve for x minus 10x minus 10x. 2x minus 8 equals 10 plus 8 plus 8. 2x equals 18. Divide 2, divide 2. X is 9. Okay, now take 9, plug it in. 9 times 10 is 90 plus 10. That's a 100-degree angle. Plug it in here for 12 times 9. That's 108. Subtract 8. So that is 100. So that's 100, that's 100, that's 100, that's 100. And the rest will be 80, 80, 80, 80. Okay, that third one is exactly like the middle one, so you're on your own. Okay, back to the algebra. Solve for p. Find the roots. Solve the equation. Find the solutions. It's all the same thing. This guy, move number 1, regardless of what you do, get everything on the same side. And I'm going to move these over to the left to try and keep my p squared positive. I'm going to plus 11p squared to this side, plus 11p squared to that side. Okay, you got 6p squared minus 19p plus 5 on the left. On the right, I got a negative 9p. So plus 9p plus 9p. And I've got 6p squared minus 10p plus 5. On the right, I got 0, which is what I want. I want nothing on that side. Okay, I'm not going to try and factor it. So I'm just going to go straight to the quadratic formula, ABC. A is 6, B is negative 10, C is 5. Okay, so if your A's, B's, and C's are wrong, you're jacked up from here on out. So just glance it over, make sure nothing jumps out at you. Maybe you can catch a mistake. If it looks pretty good, then we move on. So let's move on. I'm going to erase this and plug into the quadratic formula. X equals negative b plus or minus the square root of b squared. But if you don't put that in parentheses and you're using the calculator, your calculator will give you an error and you will be jacked up from here on out. So make sure that's in parentheses. B squared minus 4 times A times C all over 2A. There we go. Okay, now clean it up. See if you can simplify underneath the radical. This is going to be plus 10 plus or minus square root. Okay, punch that in on the calculator. Negative 10 in parentheses squared minus 4 times 6 times 5. Enter. And you should get a negative 20. On the bottom you got a 10. So your eyeballs have got to solve this problem right here. Square root of a negative. That's going to take you into the imaginaries. So 10 plus or minus, just put the imaginary in front of the radical. I times the square root of 20 all divided by 10. You know what? I don't think this is 10. 10. I don't think that's 5. So we should have all over to A, and A is 6. Gosh dang it. So, should be 12. But I think everything else looks pretty good. So I just got to change that 10 to a 12 on bottom. Okay, so that's kind of a silly mistake. A minor detail, but it's going to affect the answer in a big way. Okay, so let's go forward from here. Next, square root of 20 is not a perfect square. Or square root of 16 is. Square root of 25 is. So 20 is going to be somewhere between 4 and 5. But square root of 20, pull out some prime factors. That's going to be 4 times 5. So you're going to have 2 times 2 times 5. So you're going to rewrite it as 2 squared times 5. And since it's a square root, you can pull factors out if there's 2 or more, but you got to pull them out 2 at a time. So you're going to replace 20 with 2 times the square root of 5. So you're going to have 10 plus or minus 2i times the square root of 5 all divided by 12. Okay, now simplify the fraction. 10, 2, and 12, you can divide them all by 2. So your final answer is going to be 5 plus or minus 1i times the square root of 5 over 6. Okay, now the interesting part. Show this on a number line. And I cannot test you on this because we've never talked about it, but this is pretty cool concept to grasp, so let's do it for fun. And then maybe we'll test you later. An imaginary. How do you show an imaginary on a number line? Here's an easy one. If you have 5 plus 6i, this part is considered the real part, and this part is the imaginary. So on a number line, you'd make it look just like the coordinate plane. This number line would be the real, and your y-axis would be the imaginary. So the real, you go right 5, and then the imaginary, 6i is positive, so it's up. So your dot would be right there. That is 5 plus 6i. So you go right 5 because it's in the real direction, and then you go up 6 in the imaginary direction, and where those intersect, that is your dot. So this guy is actually 5/6 plus or minus I times the square root of 5 over 6. Okay, 5/6 is a decimal. Let me erase this grid. So if we're going to graph 5/6, here's my real, and this is my imaginary. So 5/6, there's 1. 5/6 is almost at 1, but not quite. Square root of 5 over 6, I have no idea. So calculator, square root 5, enter. Divide by 6. Square root of 5 over 6 is 0.372, blah, blah, blah. So I'm going to go right 1, and I'm going to go up 0.37, which is not very much at all, a little more than a quarter. And there's your dot. That's 5 plus I squared of 5 over 6. Now 5/6 minus I squared of 5 over 6 is going to be over 5/6 down square root of 5/6. So those 2 points, this point represents the plus, and this point represents the minus. So kind of interesting. Okay, your solutions are 5 and -3/2. Here we go. I know it's going to be x minus 5 times something equals 0, because if I plug in 5, there is my 0. 5, take away 5 is 0, but this fraction one always messes me up. So I know it's going to be plus, because that's minus, but the question is it 3x plus 2 or is it 2x plus 3? And if you can narrow it down to those two, that's awesome. You have to plug this in though, -3/2. If I plug it in for this, 2 times a -3/2, here's what happens. If you times fractions, you're either going to get a -6 divided by 2, which is a -3, and then you got a -3 plus 3, there's your 0, so this is the one you want. But check it out, you can cross cancel 2 on top and a 2 on bottom. That's what you want to have happen. So I am going to go with 2x plus 3. So your numerator is always going to be the constant and your denominator is going to be the coefficient. But then you got to put it in standard form, so you got to do the distributive property. So multiply it through x times 2x is going to be 2x squared, x times 3 is going to be 3x, and -5 times 2x is going to be -10x, -5 times 3 is -15, and then 2x squared minus 7x minus 15 is 0. Done. Standard form is ax squared plus bx plus c is 0, and you have arrived. Okay, they want you to take -1 into h. So h has one variable. You're going to replace that x with a -1. So it's a -2, and a -2 is a -4. Now take that -4 into g. G has 2 variables, so you got to plug it in once there and once there. Okay, -4 cubed. -4 times -4 times -4 is going to be negative 64, and -4 squared is going to be a positive 16. So you're going to have a -64 and a -32 for a total of -96. Same thing but on a graph. Take 9 and plug it into f. Start at 0, go over 9. F is the blue, so we're going to go up. How far did you go up until you hit it? You had to go up 3 times. So you replace this with a 3. Now take 3 into g. Go back to the beginning, 0, 0. Go over 3, go down till you hit g. I had to go down twice. So now I'm replacing that whole mess with -2, because I had to go down. So -2, start back at the beginning, 0, 0, negative, so left 2, down till you hit g. I had to go down, not quite, -1. So I had to go down -0.75 maybe. Okay, it's flipped down, so I know that it's going to be a negative. So y equals negative. This is my vertex. I had to go over 3 and then I had to go down 1. So I know it's going to be to the right is actually going to be a -3. Down 1 is going to be like that. So the negative flips it up or down. Negative is going to flip it down. In the parentheses, that's your left or right. And if it's negative, it moves to the right. So if we graph this guy, y equals x plus 4 squared plus 2. Real quick. It's positive, so I know it's going to open up. Plus 4 is 4 to the left. And then plus 2 is 2 up. So there's your vertex. It's going to look something like that. Alright, proofs. So Well, this proof is going to be quite a few statements. You want to show that the top line L is parallel to M. And here's what I would do. I would break it up. I would just look first at L and N. That's it. And I've got 1 and 2. Okay, here's what I'm given. Angle 1 is congruent to angle 2. That is given. So, all you're going to use is 4 things. Corresponding angles are congruent only if your lines are parallel. You're going to use the transitive property a ton. That's most of your logic. And then you can use a vertical pair and a linear pair. So those 4 things are it. And you just use those 4 over and over and over and over. So if I want to show that L and N are parallel, I need a corresponding angle. So I'm going to put an angle 5 right there. 5 is corresponding to 2. So if I can show 5 and 2 are equal, then I'm done. And it should be pretty easy to do because I can show angle 1 is equal to angle 5 because that's a vertical pair. So now I can show angle 2 is congruent to angle 5 because of the transitive property. Because look right here, 1 is equal to 2, but 1 is equal to 5. So if 1 is the same thing as 2 and it's the same thing as 5, that means 2 and 5 are the same thing. So now I can say 100% L is parallel to N because 2 and 5 are equal, and 2 and 5 are corresponding angles. So corresponding angles. Okay. I have got L is parallel to N. Now I'm going to focus only on N and M. And here's what I know. I know 3 and 4 are equal, so I'm going to start off with that. 3 is congruent to 4 because that's given. Same exact thing. I'm going to add an angle 6 right there. Angle 3 is congruent to angle 6 because that's a vertical pair. And I must deduce the angle 6 is congruent to angle 4 because of the transitive property. And if I just showed that 6 and 4 are congruent, I can now safely say N is parallel to M because of corresponding angles. So now check out what I did. I proved that L is parallel to N, and now I just proved that N is also parallel to M. So now in my last statement I can say L has to be parallel to M because of the transitive property. Alright, so a parallelogram. Call this line L, call this line M. And I'm going to say 1, 2, 3, 4. L is parallel to M, and these two lines are also parallel. So if I can show, here's what I want to show. Angle 1, add angle 2, add angle 3, add angle 4 equals 360. So, statements, reason. I want to show that all those 4 angles add and equal 360. So I'm going to kind of ignore the right hand side for a minute. I'm just going to play around with angle 1 and angle 2. I want to show that angle 1 plus angle 2 is 180. So I'm going to add a 5 right there. Okay, my opening statement is going to be L is parallel to M, and that is given. So we know those lines are parallel. If we know those lines are parallel, we can make some assumptions about corresponding angles. So I put 5 there because it's going to correspond with 1. So now I'm going to say angle 2 plus angle 5 equals 180 because that's a linear pair. And I'm going to say angle 5 is congruent to angle 1 because they're corresponding. So 5 is equal to 1, but 5 plus 2 is 180. Then I know that angle 2 plus angle 1 must also be 180 because of the transitive property. Okay. Now if I could show 3 plus 4 is 180, I'm done. So let's move over to the right hand side and let's add 6. So I'm going to say angle 3 plus angle 6 equals 180 because they are a linear pair. And then I'm going to say angle 6 is congruent to angle 4 because they are corresponding. So if 6 and 4 are equal, now what can I say? I can say that angle 3 plus angle 4 must equal 180 because of the transitive property. And my last statement is angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. Why? Because 180 plus 180 equals 360. Done. Did it. 1 plus 2 plus 3 plus 4 is 360. So the sum of those interior angles are 360.